Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is about Translation and Vectors Part 1. Make sure to subscribe to our channel for more lessons and don't forget to click the bell to stay notified. The objectives of this lesson are to identify a vector and determine its elements, to identify and represent the translations of a point or any figure, to recognize the equal vectors, opposite vectors, and zero vectors, to construct and interpret the sum of two vectors using Chasles rule, and finally to construct and interpret the sum of two vectors using parallelogram rule. Let's get started. Definition of a vector. A vector is a segment that shows both magnitude and direction of an object, or the force of this object force. As we have seen in the Engage and Explore section, there were two cars moving with the same speed but in opposite direction. So if we need to represent the direction of these cars, we need a vector quantity because the scalar quantity only shows us the speed of these cars, but it never tells us to where these cars are moving. And this is the main difference between vector and scalar quantity. Now let's see this example to identify in details the elements of a vector. Let A and B be two distinct points, then the vector AB is defined by its direction. Direction means that this vector is parallel to a certain line, so any parallel line to this vector represents its direction. Its sense, the vector starts from A and ends up at B. So the sense of vector helps us to read it either from left to right or from right to left. So in this example, we can't read this vector as BA. We must read it as AB because the sense of this vector is from left to right upward. Its magnitude, the length of segment AB donated by AB. So the magnitude of any vector represented by its length. Here we have a remark. Point A is called origin and point B is called extreme, and the vector AB can be denoted by U, in this example only, of course. Let's solve this exercise. Find the vectors having same direction, sense, and magnitude with vector U. So we need to compare these vectors with vector U. The vector having same direction are U, X, Z, and BA because they are all parallel to each other. Vector having same sense are U and X, Z. You see, the vector U directed from left to right, and the vector X, Z also directed or oriented from left to right, and both upward. Vector having same magnitude are the vector having same length, of course, which are U and CD. Of course, you have to use a ruler to decide or to determine the length of these vectors. Translation by vector. To translate a point from one position to another by a certain vector, you only need to represent the characteristics of this vector starting from the desired point. Let's solve an application to see what this means. Find the point M, which is the translate of N by the translation vector xz. So we need to translate N by the translation vector xz. And the rule said, in order to do that, we need to represent the characteristics of these, of this vector, starting from the desired point, which is N in this example. So the characteristics are direction first, so we need to draw a parallel line to xz from left to right because the second characteristic is the sense of this vector, and the third one is the magnitude, which is the length of this vector. So we start drawing parallel line to xz starting from point N with the same length and from left to right. And here is the point M. Application 2. Find the triangle RST, which is the translate of triangle ABC by the translation vector V. So in order to do that, we only need to represent the characteristics of vector V starting from each point of this triangle. Let's start by point A. We count 1, 2, 3, 4, 5 from left to right and 3 squares downward. 1, 2, 3, 4, 5 and 3 squares downward. 1, 2, 3. And here is the end point of vector or of the translated vector V. We plot the point R here. We do the same for point S, and again for point C we count 1, 2, 3, 4, 5 to the right, 1, 2, 3, 3 squares downward, and we plot the endpoint of vector V. And we plot the point T. And now we got the triangle RST. And you can use this method to translate any object. Equal vectors. Equal vectors are the vectors having same direction, sense, and magnitude. Like in this rhombus, we can say that KL and MN are two equal vectors because they are opposite sides in a rhombus, so they have the same length and they are parallel to each other. Also, by looking at the arrows, we can say that they have the same sense because both directed from right to left downward. Opposite vectors. Opposite vectors are the vectors having same direction and same length but opposite sense. Again, let's see the same rhombus with the same equal and parallel vectors, but this time we reverse the arrows only. So the vector KL directed from right to left, while the vector MN directed from left to right. So we can say that KL and MN are two opposite vectors. We see that opposite sense, KL directed downward while MN also directed upward. We can say that also. Zero vectors. If the origin point is the same as the extremity point, then the vector is called zero vector. Of course, if the vector ends up at the point where it starts, then it has no magnitude, and that's why we call it zero vector. Let's see this example. AA, so the origin point is A and the extremity point is A, XX, DD, YY. They are all represent zero vectors. Chasles rule or head-to-tail rule. This relation is used if the extremity point of the first vector is the same as the origin point of the second vector. Let's solve an example to understand the idea. If we have a vector xy and we have a vector yz, then if we join the tail of the blue vector to the head of the red one, the resultant vector of these two vectors will be xz vector. Because we move from left to right by xy and we go downward to the right by vector yz. And this is why xz vector will be equal to xy vector plus yz vector. You can only cancel y, and the remaining will be xz vector. But it's better to draw the triangle in order to understand the idea. But you should keep in your mind that xy plus yz doesn't equal xz. The length of xy in addition to length of yz side doesn't equal the length of xz. This rule is only represented by the vector quantity, not scalar quantity. Again, if we have a vector AB and vector BC, and we bring the tail of vector BC to the head of vector AB, then we can say that AC equal to AB vector plus BC vector. Again, AB plus BC doesn't equal AC. Parallelogram rule. We use this rule if we want to draw the result of two vectors starting from the same origin point. Like in this example, vector AB and AC starting from the same origin point, which is point A. So we need to complete this drawing as parallelogram to know or to draw the result of these two vectors. And in order to do that, we only need to use the characteristics of parallelogram. So we know that in parallelogram, the opposite sides are equal and parallel. So we start by drawing a parallel and equal line for side AC, starting of course from point B. Again, we draw a parallel and opposite, a parallel and equal line, sorry, for side AB. The intersection of these two segments is the point D. Then the vector AD is the result of two vectors. So since vector AB and AC have the same origin A, their sum is equal to vector AD, where D is the fourth vector of the parallelogram. Thank you guys for watching, and please try to contact with me if you have any question. Don't forget to solve the worksheet. Stay safe and good luck. If you liked this lesson, make sure to subscribe to our channel for more. And don't forget to click the bell to get all the updates.